Hey guys, this is 11.2, Operations with Radical Expressions. So first I'm going to have you copy down these two things. So we have like radicals and we have unlike radicals. So like radicals have the same radicand. So 4 square root of 7 and negative 12 square root of 7. If you look, they both have this square root of 7. Okay, unlike radicals are going to be 3 times the square root of 11 and 2 square root of 5. So this is what we're going to work with today. Radical expressions and combining like radicals. So my first example is combining like radicals. This is really pretty simple. If you have radicals that are the same, so look at both of these. They're both square root of 2. You have to assume that there is a 1 in front of anything that's left alone, because it's the multiplication property of identity. And then you just add the 1 and the 3, and you keep this radical. So here, if I want to simplify this, I would take negative 3 minus 4, and I would get negative 7 square root of 5. That's all you have to do. And then you leave it like that. Here I have to assume there's a 1, so I'm going to have 1 minus 5, which is negative 4 square root of 10. And I'm done. Very simple. This is the very first steps of it. Now here, if you look at these, they are not like radicals. But I can change 12 to make it look like the square root of 3. So what they did is they changed 12 into the square root of 4 times the square root of 3. They separated it out into factors. And the square root of 4 is 2. So if you look here, what they did is they just changed it to 2 times the square root of 3. So let's try one. So 3 times the square root of 20. I'm going to change that to be 3 square root of 4 times the square root of 5. Because 4 times 5 is 20. Plus 2 square root of 5. Now, I know that the square root of 4 is 2, so I do 3 times 2, which is 6 square root of 5, plus 2 square root of 5, and 6 plus 2 is 8 square root of 5, and you're done. So try this next one. Okay, so here I have 3 square root of 3 minus 2 times the square root of 9 times the square root of 3. 9 times 3 is 27. That's why I broke it up like that. And I know the square root of 9 is 3. So 3 square root of 3 minus 6 square root of 3. 3 minus 6 is negative 3. And then I just add on my radical at the end, the square root of 3. Okay, so now it gets a little bit trickier. They keep adding steps each along the way. So here, what you're going to do is you're going to use the distributive property, and you're going to see that you have a radical on the outside. What you do is you distribute it to everything on the inside. And if you look here, they did the square root of 3 times the square root of 8, or the square root of 6, is the square root of 18. You just multiply the two numbers and keep the radical sign. Here, the second time, they multiplied the two numbers, but the whole number always goes out front and the radical goes after. And then you just break it down from what we just did in the last slide. So let's try A. So this would be 2 square root of 5 plus the square root of 50. Now, I'm going to break 50, so I'm going to have 2 square root of 5 plus the square root of 25 times the square root of 2. This I know is 5. So now I have it in simplest form. 2 square root of 5 plus 5 square root of 2. And you're done. This one gets a little bit trickier because it has variables. So now what you do is you have to do the 2 times the 6, which is the 12, and x times x, which is x squared. And it all has to be under the radical sign. And then this is negative 11 square root of 2x. So here, the square root of 12 is the square root of 4 times the square root of 3 times the square root of x squared. I just broke it into 3 pieces, minus 11 square root of 2x. So this I know is 2, and this I know is x. because x squared, the square root, is going to be x. So then I know I have 2x square root of 3 minus 11 times the square root of 2x. So try the last one by yourself. Okay, so 5 times 5 is 25, and a times a is a squared, and then I just have 3 square root of 5a. Well, the square root of 25 is 5, and the square root of a squared is a, and then I have 3 square root of 5a. These do not have like radicals because this first one is not under the radical sign, so then I'm done. And then I just end there. Okay. So here, now they are going to simplify using FOIL. So what you do is you just have to use these same steps that we've learned in chapter 9 and 10, and we have to do our first times our first. And if you look here, they did the square root of 5 times the square root of 5, and they got 25. And then I do my 2 outside, square root of 5 times the square root of 15, and they got 75. And then I do my inside, square root, or it'd be negative 2, and then they do 15 times 5, which is 75. And then I do my 2 last digits. And so then they got negative 2, and then they did 15 times 15 and got 225. You're going to end with your 4 terms. And then from there, we kind of do the same thing we did before, and we either figure it out or we simplify it. So this first one, I'm going to do 2 times square root of 6 times square root of 6. So that's going to be 2 square root of 36. Okay, I'll try and color code it to make it easier for you. Minus 2 times 5 is 10. Square root of 6 times square root of 3 is the square root of 18. And then I'm going to do my inside. So then I have plus 3 square root of 18. And then I'm going to do my last digits. 5 times negative 3, or 3 times negative 5 is negative 15. And square root of 3 times the square root of 3 is the square root of 9. So now I'm going to look and see what I can simplify. Well, I know 36 right off the bat. Square root of 36 is 6. So I do 2 times 6 is 12. Okay. I know the square root of 9 is 3. And then these I can simplify. I can make them into 10 square root of 9 times the square root of 2 plus 3 square root of 9 times the square root of 2 minus 45. Okay, so now I know that these are both 3. So then I can do 12 minus 30 because I did 3 times 10. Square root of 2, I have to add that radical on. Plus 3 times 3 right here is 9. And then I have to add on the radical, the square root of 2, minus 45. Now my last step is I need to combine like terms. So I'm going to have 12 minus 45, which is negative 33. And these both have the same radical. So I can do negative 30 plus 9 and get negative 21, and then I add on my square root of 2. Look at all that work just for that one answer. So make sure you're showing your work and you're taking your time. Okay. Lastly, we have conjugates. So conjugates, write this word down, are the sum and difference of the same 2 terms. The radical expression, the negative 5 plus square root of 5 plus the square root of 2 and the square root of 5 minus the square root of 2 are conjugates. So if you look, it's the sum or difference of the same 2 terms. So these are the terms, same 2 terms, and then we have sum or we have difference. Okay? The product of the 2 conjugates results in a difference of 2 squares. So if you look at this, okay, here's my 2 terms and I'm adding them, and here's my 2 terms and I'm subtracting them. If I multiply them using FOIL, what happens is, if you remember, you don't get a B. You get an A and you get a C, and if they're squared, what happens is you square a square root and they cancel each other out, so you're left with 5 minus 2, which is just 3. So notice that the product of these conjugates has no radical. You recall that a simplified radical expression has no radical in the denominator. So when a denominator contains a sum or difference, including radical expressions, you can rationalize the denominator by multiplying the numerator and denominator by the same conjugate of the denominator. So look, here's all they're saying, okay? Here's what they want you to simplify. They give you this crazy looking fraction, 6 over the square root of 5 minus the square root of 2. What they're telling you is you can multiply the top and the bottom by the conjugate, the opposite of this. Okay, notice this is a minus and this is a plus over here. If you multiply the top and the bottom by the same thing, you will get rid of that denominator. Because you cannot have a radical expression, hence one of these, you cannot have them in your denominator. It's not allowed. So you have to multiply the top and the bottom by the opposite of this, of your denominator. So make sure you write that down in your notes. Okay, last example, rationalizing a denominator using conjugates. So if you look at this, what they did is they took this this fraction and they multiplied the top and the bottom by the conjugate of the denominator. Okay, so let's try an example. So I'm going to have 4 over the square root of 7 plus the square root of 5. And I'm going to multiply it by, I don't need parentheses, the square root of 7 minus the square root of 5 over the square root of 7 minus the square root of 5. If you remember, when you do that, you're just going to get 7 minus 5 in your denominator. So I will have 4 times the square root of 7 minus the square root of 5 over 2. Because this right here becomes 7 minus 5, which is 2. Okay, if you remember this, you keep the sign of the original one. So 5 minus 2, which is 3. So I have, I'm going to be 7 plus 5, which is 12. So you keep this original sign. Okay. Now, when you do this, you have 4 times the square root of 7. So 4 times the square root of 7 just looks like that. Minus 4 square root of 5 all over 12. If I look at this, these are different radicals, so I can't combine them, and I really can't reduce. So I could reduce my 4s and my 12. My whole numbers, if I look at them, I can reduce them all by 4. So then I would have the square root of 7 minus the square root of 5 over 3. And then you are finished. All right, that is it for your notes.